Hello everyone, welcome to our channel. Today in this video we are going to talk about the most economic section of the trapezoidal section. Here we have drawn a trapezoidal section whose depth is y and the base width is b and top width is b plus 2yz, and it is formed angle theta with the horizontal, and the side slope is z is to 1 whose horizontal is to vertical. So let's start. Consider a trapezoidal section as shown in the figure, where t can be given as b plus 2yz, where t equals top width, b equals base width of the channel, and y equals depth of flow. And area A can be given as by plus half of y times of yz times of 2 equals, on simplifying this, by plus yz y whole square. Base width B can be given as A to that of y equals yz, and the perimeter of the trapezoidal is given by b plus 2y root over 1 plus z square. This can be written as a by y times of minus yz plus 2y root over 1 plus z square. While solving this, we will carry out the process in two steps, and first step will carry out by varying y with keeping A and Z as constant. So for that, dp is divided dy equals 0 for most economical section. Or dp means placing the value of ay, this value, a by y minus yz plus 2y root over 1 plus z square is divided by dy equals 0. So on simplifying this, minus a by y whole square minus z plus z square equals 0, or a is divided by y square plus z equals 2 times of 1 plus z square equals, this is just taken to the next side. Or placing the value of a, by plus y square is divided by z square plus z equals 2 root over 1 plus z square. On simplifying this, or b plus yz is divided by y plus z equals 2 root over 1 plus z square, or b plus 2yz is divided by 2 equals of y root over 1 plus z square. This can be written t is divided by 2 equals y root over 1 plus z square. For economical section, half of top width should be equal to side slope. Now hydraulic radius r equals a is divided by p, placing the value of a y by plus y square z is divided by b plus 2y root over 1 plus z square equals by plus y square z is divided by b plus t, where the value of t is, this is the value of t. Further, this can be written as by plus y square z is divided by b plus 2y z equals times y times of b plus y z is divided by twice of b plus y z. That is hydraulic radius r equals b plus y z. This value is neglected with this y by 2. Now again, considering O as the center and OB as the perpendicular to the side, referring to the triangle OAB. So from this figure, so with respect to this O, this O as the center and OB as the perpendicular. Triangle OAB. Then OB equals OA sine theta equals t by 2 times of 1 is divided 1 plus z whole square whole root equals 2y root over 1 plus z square is divided by 2 times of root over 1 plus z square equals y. Thus, proportion of the hydraulically efficient trapezoidal channel section will be such that a semicircle can be inscribed in it. Now we'll move to case 2 of our bearing Z with keeping A and Y constant. Now for economical section, dP by dz equals 0. Now placing the value of dP, that is P is A by Y minus YZ plus 2Y root over 1 plus Z square is divided by dz equals 0. On simplifying this, this will be minus y plus 2y is divided by 2 root over 1 plus equals 0, or 2z equals 1 plus z square whole root, or z equals 1 by root over 3, or 1 by z equals root 3. This means that is tan theta, or the value of theta equals 60 degree. That is, the value of this is 60 degree. So in this, the most efficient section in this case is 1/2 of axon, 1/2 of So for this time we end up the video. After this month we'll come again with one new video. Till then, keep on watching our channel and don't forget to subscribe us. Thank you.